Okay, so one last problem for the lesson. ABCD is a square. The circle with center A and radius AB meets at the point O. Well, it meets the perpendicular bisector of AD in 2 points, of which O is the one inside the square. Find the angle AOC. So I want this angle right there. So let's look at some of the information it tells us. It's a square. All the side lengths are the same. And since the radius AB meets the perpendicular bisector of AD, that's this line YX here, it meets at O. So YX is a perpendicular bisector, which implies that these two sides are the same because it splits it in half. Now, if I said that this was X and this was X, then these side lengths would be 2X each, because it's twice as much. Alright, what else can we figure out? Well, AO is meeting the perpendicular bisector, but the radii of the circle is AB. So let's keep this in mind. Our radii is also this length here. Okay, which means that AD is also a radii of the circle. And let's just keep in mind, always we have 90-degree angles at these locations. Okay, so what else can we do? Well, I need to find this entire angle here. And I know one of the angles here is of this triangle, but we have a right triangle here. But finding like this angle is going to be tough because it's not a part of a triangle. So would be finding this angle. Let's see if we can draw any lines to help us figure out the problem. I think the obvious one might be connecting D to O. Now, why is that such an obvious thing to do? Well, because it's pretty easy to figure out that triangle AOY is congruent to the triangle DOY by, well, they have the sides YD and AY, the angle 90 degrees, and the side YO is the same, so that would be side angle side. And this is going to imply that the lengths here and here are the same, which means we have an isosceles triangle. So this angle here and this angle here is the same. Well, what else can we figure out? Well, we have an isosceles triangle. We know the base angles are the same. And these two angles here and here have to be the same as well. Now, how is that getting me anywhere? Well, if I notice AB is a radius, and the radius is defined as from the center of the circle to a point on the circle, that point B specifically. However, if we notice, that means AO has to be a radii as well, since A is the center and O is a point on the circle. which means that AO also has a length of 2x, and so does DO, because they are equal in measure based on this similarity statement we made. Well, that's interesting. We have a length of x here, and we have this right triangle AYO, and that also implies that since we have x as one of the sides and 2x as the other side, the smallest side of this right triangle and the hypotenuse is twice that length. Which means if I actually did Pythagorean theorem, we would find out that YO is the length of x times the square root of 3. Or we could just see how this is ending up as a 30, 60, 90 triangle. Because, again, we have the shorter side x and the hypotenuse 2x. Use Pythagorean theorem and you can find that YO is x root 3. So this angle here is 60 degrees because we have a 30, 60, 90 triangle. And then we have a 30-degree angle here. And we also have a 60-degree angle here. Alright, that's interesting. So I have a chunk of the angle I need. Now I just need to find this part here. Well, I know that since the entire angle at D is 90 degrees, this angle has to be 30 degrees, since 90 minus 60 is 30. Huh, that's interesting. What else can we figure out? Well, we have that the side here is 2x, but that's also the side DC, which means that we have an isosceles triangle at DOC, where this angle and this angle have to be the same. Well, I should draw it like, let's draw it like this. These two angles have to be the same because isosceles triangle at DOC. So the vertex is 30, then that means that 30 degrees, and let's just call this, I don't know, angle Y, plus angle Y plus angle Y is 180. Subtract the 30 on both sides and combine your like terms. We get 2y is equal to 150, which means that y is equal to 75 degrees. So let's clear up this diagram a little bit. I don't need the side lengths anymore. I don't really need much of these angles anymore because I've already determined that this angle right here is 75 degrees, which means the angle at AOC is equivalent, the measure is equivalent to 30 plus 30 plus 75 degrees. Now 30 and 30 is 60, and 60 and 70 is 13, or 130. So the total measure is 135. And there you have it. So even in these complicated looking diagrams, use all the information you have available. Squares equal sides. Well, what do I know about circles? The radii are equal. What do I know about triangles? Well, if I have 30 degrees here, blah, blah, blah. Use all the properties you know and bring them together, and it makes a seemingly complex problem like this one a lot more manageable.